Good morning. Myself Dinesh. I'm working as an assistant professor in Department of EEE at Adiman College of Engineering. Now we are going to discuss as a PN junction diode structure, operation and characteristics. Okay, PN junction diode. Before that, we have to discuss what is diode. Okay, diode is a semiconductor device that essentially acts as a one-way switch. In diode, this is semiconductor device. This diode is called semiconductor device. Okay, it acts as a one-way switch, but it will not allow the current in one direction. Okay, it will allow current in only one direction, but restricts the opposite direction of the current. Okay, but restricts the opposite direction of the current. Okay, this is symbol of anode and cathode. Anode is acts as a positive, cathode is acts as a negative. Okay, this is symbol of diode structure. Next, what is PN junction diode? PN junction diode. Okay, PN junction diode is a basic semiconductor device. It's a basic semiconductor device that control the flow of current in a circuit. That will control the flow of current in a circuit. It has positive P side and negative N side, created by adding impurities both the sides of a silicon semiconductor. Okay, now the anode is P-type silicon, cathode is N-type silicon. This is a structure of PN junction diode. Okay, next. Introduction to PN junction diode. Okay, it's a piece of semiconductor material. It's a piece of semiconductor material. One half is doped with P-type impurity. One half is doped with P-type impurity, and another half is doped by N-type impurities. PN junction is formed, okay, when divided into two halves or planes. When divided into two planes are called PN junction. What is P? One is P-type, another one is N-type. A small amount of pentavalent impurities such as arsenic impurity or phosphorus added to semiconductor to get the type of semiconductor. Okay, next, in addition to pentavalent impurities, increase the number of electrons in conduction band. Okay, when pentavalent impurities increase the electrons in conduction band. Okay, now see here, in P type holes, in N type electrons. Okay, in between depletion region, to flow the electric field, Okay, then third one is diffusion potential, VBI. Okay, these terms are using as a formula. These terms are going to use as using as a formula. Okay, next, as a result, number of electrons exceeds the number of volts. Number of electrons exceeds the number of volts. Therefore, electrons is majority carriers and minority carriers are N-type semiconductor. Okay, at the junction there is tendency for free electrons diffuse over the P side holes N side. Okay, this process is called diffusion. Next, similarly, immobile negative ions deposited across the P region prevents the further charge carriers diffusion from N region to P region. Okay, the cut-in voltage germanium is 0.3 volt. The cut-in voltage is silicon diode is 0.7 volt. Okay, next, operation or biasing condition of PN junction diode. Okay, there are two types of biasing. One is under bias condition, under forward bias condition. Second one is under reverse bias condition. Okay, second one is under reverse bias condition. A PN junction diode has two operations. One is N-type and P-type. The applied voltage determines the three biasing conditions of PN junction. One is zero bias, forward bias, reverse bias. Okay, in zero bias there is no external voltage is provided the junction diode, that is called zero bias. Okay, in forward bias In forward bias, P type is linked with positive terminal of the voltage potential and N type is connected to negative terminal. This is forward bias. In reverse bias, the P type is linked to negative terminal of the voltage potential while N type is connected to the positive terminal. Okay. Next, forward bias PN junction diode. When the positive terminal of the battery is connected to P type and negative terminal of the battery is connected to N type, or the PN junction is forward biased. Okay, positive terminal of the battery sinks the electrons from P material, leaving the holes there. The holes travel through the P materials towards the negative charge. PN junction partially neutralize the negative charge. Neutralize the negative charge. See here. This is a P region, this is N region. Okay. Now this is forward biasing voltage. It is very small depletion region. Very small depletion region. Okay. Similarly, negative terminal of the battery injects the electrons into N layer. The electrons move towards the N material, reach the PN junction. Okay, positive charge with result reduction of depletion region. Okay, this is called forward bias PN junction. Next, reverse bias PN junction. When the negative terminal of the battery is connected to P type of the positive terminal of the battery is connected to negative terminal of the bias applied reverse bias. During the reverse bias condition, the volts of the P side are attached towards the negative terminal of the battery and the electrons N side is attached towards the positive terminal. Okay, next, the PN junction is at reverse bias. P type is linked with negative terminal, N type is linked with positive terminal of the battery. Okay, next, due to this effect, the width of the potential barrier will be increased, prevents the flow of majority carriers. The operation performed to PN junction diode during the reverse bias condition. Next, this is a formula for PN junction diode. Okay, see, E naught is equal to VT ln Nd minus Na divided by Ni square. E naught is zero bias voltage. Zero bias junction voltage. V room temperature Vt, terminal voltage is 26 millivolts. The impurity concentration denoted by the letter Nd and Na. Eccentric concentration denoted by Ni. Okay, this is a formula for PN junction diode. Next, VI characteristics. There are two types of VI characteristics. One is under forward bias condition, under reverse bias condition. Okay. When forward bias Vf, okay, when forward bias Vf increase the current in If almost zero. Okay, this is become potential barrier, prevents volts P region and electrons from N region flow across the depletion region in opposite direction. In opposite direction. Next, under reverse bias condition, theoretically no current flow in the external circuit, but practice a very small amount of current in order to few microamperes of reverse bias. Few microamperes in reverse bias. Electrons forming covalent bond of a semiconductor. Electrons forming the covalent bond of the semiconductor. Sufficient of heat and light breaking the covalent bond. Okay. Next, the majority carriers of electrons in a P region holes. The N region over the junction flow towards the majority carriers raise small reverse current is called as under reverse bias condition. Next, see here, forward bias, reverse bias, zero bias. Same only. Okay, in x-axis as a current, voltage is taken as a x-axis, while the current is taken as a y-axis. Okay, in this diagram. Okay, in x-axis is a voltage, y-axis is a current. Okay, next, applications of PN junction diode. Applications of PN junction diode. Okay, almost PN junction diode is a rectifier. We are using as a rectifier. In rectifier purpose, in rectifier also we are using as a PN junction diode. It's converting AC to DC. Xenon diode used as a voltage regulation. Xenon diode is a circuit is used as a voltage regulation. The diode only conduct the forward bias. Okay. Next, reverse bias junction utilize the photodiode or sensitive to light. Next, LEDs is also a special type of PN junction diode. LEDs is also called as a special type of PN junction diode. These are the applications we are going to use as a PN junction diode. Okay, thank you.